Hey everybody, and welcome back to Sweatpants BI. It's me, Sean here, and this week on the channel I'm going to show you how to build a stream graph visual in Power BI. I've seen tons of stream graph visuals before. I find them attractive, interesting to look at. They kind of have this very sort of fluid or liquid movement to them. They tend to be very dynamic, and even though sometimes I do find them a little bit difficult to read, they're at least attractive to look at. I mean, personally, stream graph visuals can sometimes become as close to art, sort of abstract art, as I think data visualization becomes. But the more time that I spent in the past couple of weeks sort of looking at stream graphs and trying to understand them, the more I was struck by how do I build this in Power BI without getting too fancy, without having to download a third-party visual, without having to design it using Python or something, or bringing, external tools into the Power BI environment. How can I just build this thing using the tools that are already available to me? And of course, the answer is in the area chart. It just takes a little bit more sort of finagling and cleverness than maybe you might be accustomed to if you've built some just more standard or basic area charts. You do have to sort of manipulate and, as I'll probably say again in this channel, sort of bend the area chart to your will in order to create it, but it is totally possible. It just took me several days to sort of understand how to do it. But I got there, and that's what's important. And so since I cracked how to build a version of a stream graph in Power BI, I absolutely wanted to show you how to do it. If nothing else, it's going to at least give you some DAX practice, so hopefully that will help, because there is going to be quite a bit of DAX involved in this lesson, even though I'm confident that if you have at least practiced DAX a little bit, that it's nothing you can't handle. It's just, I'm going to walk you through step by step how to build the DAX measures that are going to sort of add up to this impression or illusion of a stream graph. So without further ado, let's go ahead and get started and jump into Power BI and get to streaming. So over in Power BI, the data set that I'm going to use to demonstrate how to build this stream graph is going to be my Lego data set that I've used for a few other demonstrations on Sweatpants BI. And the reason that I like this data set for the stream graph is that I have multiple fields that sort of categorize this data. And really for a stream graph, you're looking to use it in a data set that has, some different fields that you can use to categorize your data. Nothing too crazy. You're really looking for maybe a field that has, in my opinion, between 10 and 20 values. Let's just leave it there. The fewer values you have, the cleaner your stream graph is going to look. The more fields you have, the dirtier and probably more indecipherable that movement within the stream graph is going to look, but that varies from data set to data set. So you're going to have to use a bit of your own best judgment and sort of cosmetic judgment in deciding whether or not your data is appropriate for a stream graph. But I like this data set because we have 18,500 rows, each row a unique set that has been released by Lego. Some of its gear, think things like keychains, watches, licensed material like Star Wars Lego stuff, and all kinds of different sets running the gamut of everything that you can think of with Lego. All of their different themed and licensed Lego sets, all of their stuff that's oriented more towards younger children, stuff that's sort of oriented towards more professional builders, who want to build all kinds of different landmarks around the world from Lego sets, things like that. So we've got literally thousands of different Lego sets spanning about a 50-year period starting in the early 1970s and running through, I believe, about 2022. And I'm going to use my theme group field here as sort of the category that I'm going to use in my stream graph. You can see that the theme group category has maybe 17 values or so. Action adventure Lego sets, basic Lego sets, construction, which I'm sure is supposed to be construction. Hey folks, I didn't make this data set. That's not my typo. It is in the data. I could fix it, but I'm too lazy and it's kind of out of scope for this. But it is supposed to be construction, even though it says construction. We've got educational, model making, modern day, preschool, racing, technical, and vintage groups. And then there's some stuff that I guess can't be categorized to a theme. So we've also got a blank value here. And I'm going to leave the definition of a stream graph at the top here, because I want you to constantly be sort of thinking about this concept as I walk through the tutorial. First, the definition I pulled from Wikipedia tells us right out of the gate that this is a variation of an area graph or an area chart, which we have in Power BI, which means that if we can just sort of bend the area chart to our will, we should be able to make a stream graph. And I also want to call special attention to this part, which is that this visual displaces our data around a central axis. And that's what sort of results in this flowing organic shape. So no lie, it took me a little bit of time to sort of wrap my head around how I could manipulate the area chart to create a stream graph, even though right away I was like, conceptually, we should be able to build a stream graph from an area chart. But just getting from point A to point B took me a little bit of finagling, and eventually I got there. So we're going to show you how, and of course, this is also going to require a little bit of pre-work on our part. And the first pre-work that we're going to do is we need to set up another table that sort of summarizes whatever field we're hoping to use in our stream graph, which in this case is our theme group. Now, this is just a classic dummy table that summarizes all of these values. And if you've watched any of my tutorials, we're going to also create a row number that numbers all of these values 1, 2, 3 to however many we have. And we're going to add one additional value into this table that's going to make more sense when we get to actually building the stream graph. But for now, I need to create sort of a lookup table separate from my main data set that contains all of these values. Now, you could easily go up here and manually just copy and paste over these values, but I would recommend that you do it in DAX so that if you find yourself in a situation where you want to swap this field out with another field from your data set, you've already got everything sort of set up behind the scenes to do that, and you don't need to, copy and paste a new table. We're just going to go ahead and do this in DAX so that we've already got everything that we need happening behind the scenes here. So let's go up here to modeling, and we're going to model a new DAX table. Doesn't matter, whoops, and there goes my table. Let's go ahead and do that again, and this time I'll try to actually click on the screen. And it doesn't matter what you call this table, but I usually call my summary tables or anything that's kind of separate from the rest of my model, I usually call it Z underscore, meaning that this table's just not actually hooked up to my main Lego set behind the scenes. There's not going to be any relationships. This is going to be a disconnected table. And all I'm going to do here is I'm going to keep this super simple, and I'm just going to use the summarize columns function to summarize my theme group field. And I think it'll be easier to follow along from here if I go over to the table view, so that you can see by using the summarize columns function, all it did was it just basically pulled the distinct values from the theme group column of my Lego set. Got it? Good. Okay. So now let's go ahead and add a new column to this. And we're going to call this column sort. You can call it order, you can call it whatever you want to. Just know that the column that we're going to create now is going to number all of these values 1, 2, 3, 4, all the way to 17, since there are 17 rows in the table. For this sort or row number field, I'm going to use, I believe, a newer DAX function called row number. And I'm going to tell this row number function that I want you to take all of the values in my theme group field, and I want you to create row numbers based on those values, and I want to make sure that those values are ordered based off of the items in theme group. And after the DAX processes, you can now see that I have row numbers here, and of course they all run alphabetically based on the values over here in my theme group. So blank is 1, action adventure 2, arts and crafts 3, and the rest is just alphabetical. Now, what we need to do is we need to add one more row manually to this table. And I guarantee that at first you're going to be like, Sean, what are we doing? This sounds intense. Don't worry about it. It's all going to make sense when we actually start building the stream graph. And all I'm doing with this spacing now is just giving you a little bit more room to read this. So I'm just going to use a simple union command, and I'm just going to manually stitch one more row onto this table. And for this, since this row is completely manual, I'm going to use the row function and just type in exactly what I need. So you can call this whatever you want to. I'm just going to call this row. You could call it theme group. It absolutely doesn't matter what you call this because it's just going to get appended to our theme group column. And I'm going to call this new value offset. And this offset value is going to appear right down here under arts and crafts. Next, I'm going to need to add another value to my sort column, and you can give this a number of 18. That's fine, whatever you want to call it. You could give it 18. I'm actually going to give this one 0 as the number. And so there's the row that I just manually appended or unioned to my table here. And this row that we have inserted, this offset, is going to be essential for creating the stream graph effect that we're going to need to sort of manipulate the area chart into creating our stream graph. So I'll show you how. Just remember that for now, this is just a manual row that we have added to the bottom of our theme group summary table. Which, by the way, while I'm here, let's go ahead and just change this to theme group. Okie dokie. There we go. Okay, so we've got our new table. It's over here behind the scenes. I'm just going to go ahead and show you. It's right here. And again, it's not connected to our data set. It's just a DAX table that is hanging out here by its lonesome, waiting for us to do something with it. Okay, now it's DAX time. Let's go ahead and add a new measure table here. And I'm going to call this measure table stream graph measures. Should appear, because I gave it an underscore, it should appear up here at the top. And the first thing that we're going to do is let's go ahead and do a little bit of pre-work here. And let's go ahead and just grab a matrix real fast. And I just kind of want to demonstrate what we're doing and why. So I'm going to go ahead and build a matrix here. And this is just for demonstration purposes. You can either build along or you can just watch me do this. And let's go ahead and grab our year, because year is what we're going to use on the x-axis of our stream graph. And of course, these theme groups are the categories that we're going to use in the legend value of our area chart or stream graph. So we've got our Lego sets. And what we're basically trying to show here is the evolution of the number of Lego sets being made over time in these different theme group categories. So another way of sort of thinking about the stream graph is we're basically building a weird version of a stacked 100% bar chart. So if I add all of the components that I'm going to be using here, this is basically what the stream graph is going to be representing, just in a very different way. So you can see over here in 1970, a lot of my stuff was vintage. That kind of phased out in the 80s. And then by the time you get into more recent years, almost everything, almost all of our kits can either be, or Lego sets can either be categorized as miscellaneous or as licensed. So this is still basically the story that our stream graph is going to be capturing. We're just going to need to visualize this data, not as percentages, but as sort of counts relative to each other. And we're also going to be sort of distributing this data and these changes around a central axis. And so the first thing that we're going to need to do is we're going to need to create that central axis. Now, for the purposes of the stream graph that I'm going to show you, it doesn't really matter too much if you use the x-axis as your central axis, or if you create one manually. And I am going to create one manually for this demonstration. So let's go ahead and create our first measure here. And for this measure, I'm going to use the average number of yearly sets across the entire 50-year time frame as my central axis. And then I'm going to build my stream graph around that. So let's call this average annual sets. And this is going to look something like this. I'm going to be calculating an average x function or measure. And I'm going to be calculating this average x around all years in my data set. I'm going to use my Lego set count. And let's just go ahead and start with this measure before we add anything onto it. So currently I've just got my Lego sets in this matrix. Let's go ahead and add our new measure here. I'm going to go ahead and hide this column so that this becomes a measure table. And okay, right now you can see that I've got 4 and 4, 22 and 22, 13 and 13. Right now, these two measures are still basically equal to each other. So let's go ahead and add one more element here, and this is going to be, I want this to be calculated for basically any value from my, or any field that I'm using from my Lego sets field. Just roll it all together. And so this gives me 348 as the average number of Lego kits being released across any given year. So you can see 348.25 is what I've got for everything. So with that, we're going to go ahead and start actually building out the bones of our area chart. And I'm going to start with just a regular old line chart so that I can show you how these different measures are being evaluated. And we're going to switch this to an area chart right at the very end so that I can show you the stream graph. So we've got our first measure here. Let's go ahead and add year to our x-axis, and let's go ahead and grab our average annual sets. And you can see it's that 348.25. And it's being evaluated that way for every single year, which is what we want. This line becomes the central axis around which we're going to build our stream graph. So we've got our central axis now for, we're just using average annual sets. Doesn't have to necessarily be average annual sets for you per se, but I just wanted to sort of show you what we're doing. Another key piece of this stream graph puzzle that I'm going to need is the percent of annual sets by theme group. And for this measure, we're going to be dividing our Lego set count by however many Lego sets were created in the given year. So I'm going to use calculate. We're going to recalculate our Lego set count, but this time I'm going to restrict filtering by theme group by using all selected. This should give me a new percentage so that I can see and let me go ahead and clean this up a little bit. This way I can see for any given year what percentage each category made up of all of the sets that were released in that given year. So I've got in 1970, I've got 4 basic sets. That made up 9.8% of all the sets released in 1970. Over here, I've got 1, that's 2.4%. 7 modern day sets, that was 17.1%. And then over here at the very end, I've got vintage, which was 27 or about 66% of the groups. And if you remember in the stacked 100% bar chart, vintage was our most popular Lego set type being released in the first decade of our data set. And of course, if you're doing this correctly, all of your years should be 100% over here. So that tells us that we're on the right track here. The next thing that we're going to do, and I'm going to go ahead and just clean out some of my measures here. I'm just going to leave my Lego sets here. The next thing that we're going to do is we're going to create a measure that always pulls the maximum number of sets for each year. So for 1970, it's going to be 27. For 1971, it's going to be 69, then 22, then 47, and so on and so forth. So let's go ahead first and grab our max annual sets. We're going to use max X and all selected to grab our maximum number of sets across all theme groups. Let's go ahead and drop this in here and make sure that it's correct. Max annual sets is 27 for 1970, which is correct. It's coming from vintage. And you can see that it's always vintage for the first ones. Then in 1978, it switches over to 40, which is technical. So just know that the max annual sets for each given year is showing the number that corresponds with the maximum number of sets released across all of our different theme groups. We're going to do the same thing here with min, even though I don't believe that we're actually going to use this measure, but I just want to sort of show you how the min x function works. It does exactly the same thing, but instead of looking for the max, it's now looking for the min. 1, 2, 1. So you can see for each given year, it's pulling whatever the minimum number of sets was that was released for one of the different theme groups. So it's 1 here, which probably corresponds with preschool or modern day, or let's see, miscellaneous. So there we go. So the next thing that I want to do is I'm going to go back over here to my stream graph, and I'm just going to drop these in here so that you can see what those two functions are, what those two measures are doing. My min is always pretty low because there's always going to be a theme group that releases, you know, only a handful of sets in any given year, whether it be 1970 or 2022. However, as LEGO grows, some of its theme groups are really taking off. So we have, you know, especially in the year 2000 on, a few of our theme groups looks like they're releasing an incredible number of sets. So you see this huge spike where the max annual sets continues to increase. So what I'm going to do now is just disregard the min annual sets. I'm not really going to use this. I'm going to use my max annual sets measure to create the shape of my stream graph around my, what's the word that I'm going for here? My central axis, which is my average annual sets. So what we're going to do is we're going to create next the sort of the shell or shape of our stream graph. And remember, a stream graph should be kind of a mirror on either side of the axis. You know, any spike that you see above the central axis, you should see a corresponding valley in the same area below it. So we need to take one of these measures and use that to shape our stream graph. And I'm going to use max annual sets instead of min annual sets. I think it's going to make a lot more sense for this data set. So let's go ahead and create our first band. And I'm going to call this high. And this is going to be my average annual sets plus my max annual sets. And I'm going to go ahead and grab my band high measure. I'm going to drop this on here. And now you can see it's exactly the same function, but now instead of being relative to, or exactly the same measure, but instead of being relative to the x-axis or 0, it's now using my average annual sets as the axis. So that's why you'll notice that the orange line and the red line look identical. They're essentially the same measure. It's just one starts relative to the x-axis, which is 0, and the other starts relative to max or to the average annual set. So let's go ahead and get rid of max annual sets. Now, I'm just going to copy this because now I need to sort of create the mirror image of this line. So I'm going to call this band low. And instead of adding, I'm going to subtract. And this is going to be the mirror image of my high band. So let's go ahead and drop that in here and see what I mean. Now you've got the mirror image. Now here I want to interrupt the video for just a second because I'm actually recording this after I already did the tutorial. I want to go back and just sort of emphasize, you don't necessarily have to use the max or the min or anything to create those two bands. In fact, I could have just used the Lego set count itself, and you would have seen that volatility. And then if I flipped that around by subtracting it from the average, you would have seen it going in the other direction. So I just want to emphasize that I used a max measure because literally for no other reason than just when I was practicing this technique for stream graphs on another data set, that was just the function that I used. I want to be clear, you could use a different function and even, you know, cut out the max and the min stuff entirely. The only thing that you need to do is you need to create your central axis, which in this video I used the average of all Lego kits released across the entire 50-year time frame. And then on top of that axis, added a measure, which again, you could have just used the count of all Lego sets and then subtracted it to get the mirror image below that. That would have been fine. It has some, whatever measure you choose is going to have some implications for the overall shape of the bands that make up your stream graph. It's not really going to make that much of an impact on how the colors within your stream graph move or how they look relative to each other, because all of those are going to be weighted which I'm going to talk about here in the video in just a second, they're going to be weighted by whatever proportion your categories make up for a given year in your time frame. So because the weights are not going to be impacted by how we set up the bands, you don't have to really worry as much about like which items are going to stand out over time or even getting the wrong answer. But I thought that it was confusing after watching this video in retrospect that I used a max measure when really I didn't have to for this specific example. So I hope that makes sense. I just want you to know that, what I'm trying to highlight here is just that you need to create some sort of measure to use as your central axis that is that horizontal line that runs across your chart. And then you need to pick a measure from your data set that you want to put on top of that central axis and then mirror it below the axis. The next thing that I need to do is I need to create a delta between these two bands, which is just going to be band high minus band low. And I'm just going to hold on to that band delta for a moment. And let's take a quick breather here to sort of talk about what's going to happen next with the remaining functions that I have to write. What we're going to do is, there is a set distance or delta between my high band and my low band. What I want to do is I want to take whatever this delta is, which here it's whatever the delta is between 348.25 and negative 64.75. Let's just call that, a little over 400. And I want to allocate that 400 delta. I want to allocate that between my different theme groups, which is why I'm really going to need to know what the weights are over here that I had created. Because, again, we're basically taking the weighted values of all of our different categories here, these theme groups, in order to create our area chart. So if you'll remember over here, it was 9.8% goes to basic for 1970, 2.4% goes to miscellaneous, 66% goes to vintage. So over here, 66% of the delta here for 1970 should be allocated to vintage. And when I get to 2022, let's go ahead and scroll down to the bottom of our table. By the time we get to 2022, 25% of that delta is going to be allocated to licensed. 42, almost 43% is going to be allocated to miscellaneous, about 11% to modern day, and everything else is going to be super small. So, and also another thing to keep in mind here too is that eventually we're going to incorporate the theme group category, but we're not going to be using the theme group category from our Lego sets. We're going to be using the theme group category from the summary table that we created that's not hooked up to our data. So let's go ahead and start by creating a new measure here. And this measure is going to be very similar to our percent of annual sets measure, but we're going to calculate this for our summary table. So in order to demonstrate this, I'm going to go ahead and copy everything over here. And I'm going to go ahead and swap out the theme group from my Lego sets table with the theme group from my summary table. And you'll see that this breaks the logic of my percent of annual sets by theme group, because the reason that they're showing 100% for everything is that there is no relationship between these two tables. Power BI has no idea what to do with the values in my theme group summary table, so it's showing 100% for everything. If I were to grab my total Lego sets measure, it's going to also do the same thing. Now you'll notice year, of course, comes from my Lego sets table. So year is filtering just fine. That's why I've got 41, 78, 45, 76, but notice that those values are the same for every theme group. So at 41 all the way across, 78 all the way across, because Power BI does not recognize how to sort of join these two fields together. So I'm going to need to create a new version of this measure where I tell it what to do with values from my theme group summary table. So I'm going to create a new measure here, and I'm going to call this mix. Even though this does exactly the same thing as my percent of annual sets, it's just retooled for my summary table. And for this one, I'm going to be dividing again, but this time I'm going to change how I'm calculating my Lego sets. I'm going to grab my Lego sets measure, But I'm going to give it some additional instructions here. I'm going to add a filter clause here, and I'm going to tell it, I want you to filter this measure based on any instances where theme group is equal to whatever value is being evaluated for the theme group from my summary table. In other words, always return this measure, but filter it for whatever theme group is being evaluated in this visual. And remember that these items come from my theme group summary table. Next, once I have that, I can just divide by my regular Lego set count. The reason that I don't have to do any additional manipulation on this measure is my Lego sets are already correctly filtering by year. My year is always coming from my Lego sets main table. So once we go ahead and apply that, I can go ahead and click on my table over here. And I'm just going to remind you that, again, my original percentage measure does not work at all. But once I changed that measure and told it how to evaluate or how to compare the theme group from my main Lego set and the theme group from my summary data set, this new measure should work just fine. And you'll see I've now got, first I need to format this as a percentage. But yeah, there's my 9.8%, 6.4%, 4.4%, and 30.3%. And you might be thinking, Sean, you just went through a lot of trouble for that. If this measure was working, why not use this measure? And why not use the theme group from your main data set? And that is where I want to remind you about the additional row that we added to our summary table for this offset. I need this offset row. I need it desperately to make my stream graph work. And of course, this offset value doesn't exist at all over here in my main Lego sets data set. There is no offset field. So we need this. We need to utilize the summary table, or I wouldn't have built it. But that unfortunately means that we needed to get a little bit fancy with our DAX. So from here on out, everything gets relatively easy. We're going to create one more measure here. And this measure is going to be called mix times delta. And that's exactly what we're doing. We're just multiplying mix times our band delta. And I'm going to go ahead and head back over here to our stream graph. And this thing is going to look an absolute mess when I first do this. But let's just go ahead first and set up our stream graph measure. And let's go ahead and just call this stream graph. And now here is the rub, so to speak. This is where I'm going to reference that offset row. And you'll remember that that offset row over here, I'll go ahead and break the measure just to show you. That offset row down here at the bottom has a sort value of 0. So what I'm doing here is I'm telling Power BI what I want it to do whenever it finds that offset category. And this is where what I want it to do is I want it to reference this band low line. What this is going to do is, because area charts by their very nature are going to start at the x-axis, I'm going to create a kind of a hidden value that allows me to stack all of the values that I'm interested in on top of this low band. This is how we're going to distort the stream graph in a way that is going to help us sort of create that illusion, because this is kind of an illusion that we're creating. So whenever it encounters that offset value in our category summary table, it's going to reference the band low measure. And when it doesn't, it's going to use mix times delta. And this is how we're going to build our stream graph. So first things first, let's just go ahead and scrap everything here. Let's go ahead and turn this into an area chart. And let's go ahead now and put our stream graph into the y-axis. This might look terrible at the moment, but it's going to start to look a lot better here in just a second. I'm going to grab my theme group field from my summary table. I'm going to drop that into the legend, and you're like, oh my God, Sean, it looks terrible. But it doesn't really. Let me show you what's really going on here. So right now, Power BI has still just defaulted to stacking everything based on the alphabetical values of my categories. That's not what I want it to do though. I'm going to click on my theme group field here. I'm going to go up here to my sorting options, and I'm going to tell it, hey, sort these theme groups using the sort field. Now something has happened. You're starting to see the shape of the stream graph, but you've got this huge purple area here. What is this purple area, you might be wondering? And that, if you look up at the very top of the tooltip under 1995, that is our offset. Notice how much bigger the offset is than all of the other values that I'm hovering on. 330, 331, 317, 327. This offset is something that we're just going to hide. So let's go ahead and head over here. We're going to go to our lines. I'm going to click on my offset field, and I'm just going to give that a color of white. And now it's gone. So see, we have basically hidden that offset, and what we're left with is our stream graph, which just needs a little bit of cleaning up now. So, because you'll notice that there's also these lines that are sort of, extending all over it. And that is because these just represent instances where there's a theme group that is present 1 year, and then maybe it disappears for several years and comes back. Like whatever I'm hovering on here, there's a brown dot here, and then there's one there, and then it's gone, and then it's there. And then it disappears for like a decade and comes back in 2000. If you want to clean up those ugly lines that just kind of come and go, I'm going to create another stream graph measure. And for this one, I'm going to give it just additional instructions where I'm telling it, hey, if stream graph, if the measure that I'm evaluating, if it equals 0, then just let it be 0. Otherwise, use the measure. And now when I swap these out, let's go ahead and grab my new measure. Those random straight lines that kind of interrupt the flow of our stream graph, they vanish because now they're just being sort of folded into everything else. So we've basically got our stream graph. Now it's just time to start making it look a little bit more stream graphy. So, something that you might want to do here, first, I would go ahead and say, just get rid of the y-axis entirely. We're demonstrating something here that's much more strictly speaking visual. We're not necessarily interested in the precision. We're interested in spotlighting the changes in these theme groups more so. So I'm going to go ahead and update my x-axis. Let's go ahead and blow that up. I'm going to turn off the title here. Next thing that I'm going to do is let's go ahead and manipulate our lines a little bit. I'm going to go up here to all. And instead of using linear line types, I am going to smooth these out just a little bit. And I'm going to decrease the stroke width. And for my shade area, I'm going to go ahead and just drop that down to about 20. It's still really, really loud, too colorful, but we'll fix all of that here in just a second. I'm also going to add a zoom slider, but not for my y-axis, just for my x-axis, so that if users are interested in sort of expanding this out and just looking at a specific year, they can do that a little bit more easily. The next thing that I'm going to do here is let's go ahead and, let's go ahead and add a bar chart over here. And I'm just going to grab my theme groups and my Lego sets. And I'm going to filter this so that I'm only looking at years greater than, let's just look at things in the 21st century. So the reason that I'm doing this is there's a lot happening over here, right? There's a lot of noise. This is a noisy visual. What I'm going to do is I'm going to spotlight miscellaneous, licensed, modern day, maybe action adventure, and maybe preschool. But I just kind of want to be able to reference these as I swap out my colors over here. So let's go ahead and open back up our lines here. I'm going to go down to my colors. And for many of these, I'm just going to let them be different shades of gray. Preschool is my first one that I was considering, possibly giving some color to. So let's try giving that kind of bright magenta. Modern day is another one. Let's see. This can be gray. Miscellaneous is, of course, a huge one, the biggest, in fact. Licensed is a huge one. Then junior. Don't get too hung up on the colors here. I'm moving pretty quickly. All I'm trying to do is really just create enough visual distinction that I can at least focus on the things that I want to focus on. And then of course, if you decide you don't like the colors now seeing it in context, change them up a little bit. Let's go ahead and try, okay, I've got action adventure down there, followed by licensed, followed by miscellaneous. Let's try making that like so. Those two colors are pretty close to each other. Okay, next I'm going to go ahead and just hide my legend, and let's go ahead and turn on our series labels here. And you can decide how much detail you want to get into here. I'm definitely interested in turning off a lot of these labels. I am going to leave preschool on, and modern day model making gets turned off. Miscellaneous and license get left on. Turn off junior, historical, girls, education. Construction drives me nuts. Every single time I say it, I'm just like, ugh. And arts and crafts, and of course blank. And of course, we absolutely don't want offset to be visual or to be visible on the chart. Once we have those, let's just very quickly sort of run through again, starting with action adventure. Let's go ahead and change this up a little bit, make it a little bit bigger here. Let's make sure that we're using the same color that we're using in the stream. Next, I'm going to go up here to licensed and do the same thing. 13. Let's go ahead and make this the same color. Next is miscellaneous. DIN 13. Using our yellow here. After that, what's next? Modern day. DIN 13. Bold. There we go. And our last one is going to be preschool. DIN 13 and that color. And one thing that I am noticing, of course, is action adventures getting cut off. Let's go ahead and change this back to all. And let's go ahead and increase the maximum width a little bit. 10 doesn't seem to be doing it, but we can keep punching that up until everything fits. And when we're done, let's just go ahead and drag this back out so that we can more easily see our stream graph. So again, on the whole, the DAX was not all that difficult to build the stream graph. You walking through it step by step, I know it was like, oh man, Sean, it took us like 10 or 11 measures to get there. But you wouldn't necessarily have to do it that way. I did it in 10 or 11 measures so that you could see every single step in the process and sort of how all of those items sort of relate to each other to result in an area chart being sort of manipulated into creating a stream graph. You could probably do it in fewer measures. I would say that, with so many nested measures involved, depending on the complexity and size of your data set, you could conceivably run into some performance issues, even though none of the DAX, in my opinion, is terribly difficult that's required to make it. But still, I thought that it was a very sort of aesthetic and flexible way of building a stream graph. The beauty is I used one field from my Power BI report, but you could easily, click through all of the DAX measures in your summary table and swap out the field that I used with a different field from your data set. Or experiment with multiple fields from your data and create multiple stream graphs. It does take a little bit of work going through all of your DAX and just swapping out one field for another, but you should be able to use any field from your data set the same way And you should also be able to use any fields that might, sort of transcend or run across different tables in your model, as long as they're all obviously, connected to your and have relationships, except for your summary tables that you created in DAX. So it should be a pretty scalable and flexible way of creating a stream graph that I was able to use across multiple Power BI reports and data sets. Hopefully it'll be the same for you. So anyway, hope you enjoyed that I don't know if I'd call it quick, but hope you enjoyed that tutorial on how to create a stream graph. If you have any other ideas for cool data visuals that can be built using the native tools in Power BI that other people may not know about, I'd love to know about those examples so that I can see if I can figure it out. Maybe other people who watch the channel feel the same way, so sound off in the comments with what those visuals are. And as always, thanks again for checking out Sweatpants BI. If you enjoyed this content, let me know about it. And of course, feel free to like or subscribe to the channel. It helps me out a lot. Otherwise, it's been great having you again. I'm Sean. This has been Sweatpants BI. Hope you have a great week, and I'll see you next time.